Meta is giving away its best AI models for free. Seriously. And honestly, it's kind of brilliant. But to understand why they do that, we've got to zoom out and look at the whole picture. Let's dive into this explainer and decode the massive, complex ecosystem that's actually powering the global artificial intelligence boom. We hear about it literally every day, the investments, the breakthroughs, the sheer scale of ambition. But what does all of this actually look like under the hood? Now, you might be wondering, why are the world's biggest tech companies spending absolutely mind-boggling billions on infrastructure? Well, to understand the headlines, we really have to look at this like a modern gold rush. Think back to the 1800s, right? The people who consistently made the big money weren't necessarily the ones panning for gold in the rivers. They were the ones selling the picks and the shovels. Today, tech giants aren't just building consumer apps and crossing their fingers, they are fiercely buying up the digital picks and shovels. They're laying down the infrastructure that's going to define the next era of computing.
Here's how we're going to break it all down today. 1. The AI spending boom. 2. The hardware foundation. 3. The software ecosystem. 4. Building the AI factories. 5. AI in the real world. And finally, 6. The hidden costs. Let's get right into it.
Section 1. The AI spending boom. The race for dominance and talent.
Just look at the rapid-fire headlines hitting us almost weekly. They completely validate the sheer urgency, honestly, the panic of these investments. Alphabet is massively ramping up their spending just to keep pace. Oracle and OpenAI just signed a mega deal that totally blindsided Wall Street. And then there's Meta. They just dropped their biggest OpenAI model yet. They are essentially giving away incredibly powerful tech for free. Why? Because it builds a massive open-source ecosystem around their products, turning that community into a massive competitive moat. Meanwhile, startups like DeepSeek are jumping in and completely puncturing the established spending plans of the market leaders. It is a chaotic, high-stakes arms race.
And you know, this arms race isn't just about servers and chips. There is a ruthless war for human capital going on right now. Tech giants are literally drafting top AI talent like they're professional athletes. There is a very finite pool of engineers out there who actually know how to build these massive foundational models. And the bidding wars to secure them, they are just astronomical.
Section 2, the hardware foundation, the picks and shovels of the AI revolution.
So what exactly are these billions buying? To keep it straight, we really need to separate the foundational hardware from the software stack running right on top of it. On the hardware side, you've got highly specialized equipment from NVIDIA, stuff like their Grace CPUs, Hopper architecture, and the newer Blackwell GPUs. They are the undisputed supplier of those digital picks and shovels. But hardware is literally only half the story. You also have the software layer, like the CUDA platform, Nemo for AI agents, and Omniverse for digital twins. That's what actually lets developers harness all that raw silicon.
Let's zoom in on that hardware for a second. The crucial point here is that chips like Blackwell and Hopper aren't just standard processors you'd find sitting in a laptop. They are explicitly being dubbed the engine of the new industrial revolution. This architecture is designed to deliver high performance, insane scalability, and deep security for the modern data center. It's the physical bedrock that makes generative AI mathematically possible.
Section 3. The software ecosystem. Tying the hardware together.
Now, it's super easy to look at the AI boom and think, oh, this was an overnight success. But if we look back over the last couple of decades, it paints a totally different reality. Software ecosystems like CUDA have been painstakingly built up over 20 years, from the very first compute kernel way back in 2006 to powering global AI dominance looking ahead to 2026. This software layer is exactly what transformed basic graphics hardware into the incredibly flexible AI platforms we rely on today. This 20-year head start, that's exactly why this ecosystem is so incredibly hard for competitors to replicate.
Section 4. Building the AI factories, scaling up to supercomputers.
400. I really want you to consider that number for a second. It brilliantly illustrates just how dominant this tech is. NVIDIA technologies now power over 400 of the world's 500 fastest supercomputers. That means 81% of the top 500 list is built on this exact infrastructure. We aren't just talking about your standard corporate data centers anymore. We are talking about the absolute bleeding edge of global scientific computing power.
And it's not just tech companies either. Global governments are going all in. A perfect example is Europe's Jupiter supercomputer. This is an absolute beast, an exascale machine, using this same fundamental architecture to push the boundaries of science. They're using this massive AI factory to run advanced simulations for climate modeling, deep brain research, and even the development of future 6G networks. It's computing on a scale we literally couldn't imagine just a few years ago. Section 5, AI in the real world, escaping the data center.
So, what happens when AI escapes the data center? We're seeing specific software platforms drive very real, tangible innovations across heavy industries right now. With the Isaac platform, we're seeing massive leaps in robotics and edge computing. The Drive platform is totally advancing autonomous vehicles, with companies like Mercedes-Benz integrating it for top-tier safety and self-driving capabilities. And with Omniverse, major manufacturers are creating what they call digital twins. These are perfectly accurate digital simulations of their factories so they can test and optimize everything in software before they ever lay a single physical brick. How cool is that?
Which brings us to the rise of what's being called physical AI. We are moving way beyond standard chatbots and image generators here. Foundation models like the new Cosmos 3 actually allow autonomous machines and vision agents to reason, simulate scenarios, and interact with the physical world. It's all about taking that raw data center intelligence and putting it into physical robots and vehicles that can safely navigate our everyday environment.
Section 6, the hidden costs, energy demands, and the path to profit.
But hey, let's bring this narrative back down to earth for a reality check, because building out these massive infrastructure layers exacts a really heavy toll. Microsoft, for instance, recently had to announce a huge glut of new data centers just to keep up. But where do those go? How are they powered? Recent reports highlight that a lot of the AI tools we casually use every day are essentially running on fracked gas and bulldozed Texas land. These AI factories demand a massive real estate footprint and surging, truly unbelievable amounts of electricity and water. The physical footprint of our digital future is honestly pretty staggering.
And on top of that, even with billions upon billions of dollars spent, the technology itself is hitting some friction. Industry leaders are admitting that progress doesn't always match the crazy hype. Mark Zuckerberg, for instance, recently told his staff at Meta that their AI agents haven't progressed as quickly as he'd hoped. So there are very real technical walls we're still hitting, and every attempt to climb over them costs another $1 billion.
And that leaves us with the ultimate question for this era. As the infrastructure costs just keep piling up, as the demands for real estate, energy, and elite talent completely skyrocket, how long can the tech industry actually sustain this gold rush before these systems have to turn a real profit? Are we laying the groundwork for a permanent new industrial revolution, or are we just inflating a bubble built on expensive microchips and megawatts? It is the multi-trillion-dollar question, and the answer is going to define the next decade of technology. Thanks for joining me on this explainer. I really hope it gave you a clearer picture of what's actually happening under the hood of the AI ecosystem.